right? So any exponential function, y equals a times b to the x. A is considered your initial value. So that's where I would have put the penny in there, 0.01. B, and we're going to have different looking B's, right? But B is your base. Sometimes we're going to call it our growth or decay factor. And there's kind of some rules on the B. Okay, there's going to be some rules on the B. So before I tell you the actual rules on the B, let's have you guys kind of think about them first with your partner. Okay? So if I were to plug numbers in, so I'm going to give you some different situations. All right? If I were to plug in some numbers like a half, a third, a seventh, right? And again, if you have a calculator or you want to open Desmos, you can feel free to do that, right? And you can just make A1, that's fine. So do you think that could be a half to the x, a third to the x, a seventh to the x? Do you think it could be negative a half, negative a third, negative 1/7? And if you were to put that in your calculator or Desmos, it would need to have a parenthesis around it. All right, if you don't have Desmos or you don't have a graphing calculator, you can just kind of make a table of values, right? You can make a table of values and see what happens. All right, so we got some fractions going on. All right, so now let's think of regular numbers. The number 2, the number 3, the number 7. So then let's think negative 2, negative 3, negative 7, right? What's going to happen with those? So then I have two specific numbers that I want you to try. I want you to try the number 0, and then I want you to try the number 1. All right? So if you don't have a graphic calculator, open up Desmos. And again, A can be 1, right? A can be 1. Try putting those equations in and see what the functions look like. And if there's only like one person in your group needs to open it up, right? So see what those equations look like when you put numbers like a half, a third, a 7, or try to plug some numbers in and see what it looks like. Right, so I'm going to tell you, we have 6 different cases here, right? I've got 5 bullets, but then on these 2 bullets, I have 2 different situations. So I kind of want you to tell me, what bullets do you think will work versus bullets that you think won't work? Okay, so you can put them in a graphic calculator, you can put them in Desmos. All right, so like a couple minutes. Call full of minutes. Do that, please. So you can just put in the base as like
Oh, yeah.
or like 0.5.
First day you have 0. Second day, third day, got 0. Got nothing.
Just like, yeah, and Desmos, you gotta go y equals like a half to the x.
First day you
How do you what? The little carrot symbol will give you the power. We're gonna go the other ones.
Oh, yeah. No, okay.
Do you guys all, I don't know if I have an graphic calculator, let me see if there's a
No, it would just stay the same. Yeah, you're right. You would have to be plus. And then 0, you could you have the possibility of actually going down, right? Because let's say if you start at 5, for instance, you're at 5, and then the base is 0, so then you but you still lose. It still goes down to the point and this is 0, right?
Also,
Or was the first one just start at 0? Like you just start
Okay, somebody's muted, yeah? I got 6 calculators, guys. If a group doesn't have one, you can come and grab one. But I only got 6, so don't have groups take 2. Does anyone have any that you definitely know is going to be an issue? Sorry, change those 3. You just sit outside. Yeah. Does anybody know? Does anybody think they're sure that any of those situations are issues?
Yeah.
Any ideas?
So it would be like.
So Alex has one of them, and she has a half to the x. And her half to the x looks like the bottom graph. So that's what you're looking for. You're looking for them to look like the top or bottom graph. Right? So the half to the x worked for her. So I'm going to think if she just changed that 2 to a 3 or to a 7, right, that it's still going to be the same. Right? So if I put my equations in here, right, so 1/2 to the x or 1/3 to the x, 1/7 is going to look the same. So I'm just going to zoom 6 it, and those are 2 graphs. So first category, check mark, right? It works. Let's go back to analyzing graphs, right? We did domain, range, vertical asymptotes, horizontal asymptotes, x-intercepts, y-intercepts. Increasing, decreasing, constant. What does that do? Is that increasing, decreasing, or constant? Okay, read left to right, right? So decreasing. So we're going to write all this down in a second, right? But this section works, and it's a decreasing graph. All right, so since I have those in there, let me stick a negative in there. All right, let me stick a negative in there. Did anybody try this set yet? Right? Paxton, was that you? Did they work? You thought they worked. Let's see. All right, so did you put it in just like that? Did you do the parentheses? You got to do the parentheses. Right? You got to do the parentheses, because if you don't do the parentheses, all it's doing is a flip over, right? A transformation. Right? And I am just going to put one of them on right now so you can see. Right? I'm just going to do the negative 1/2 to the x. So I've got a 10 by 10 window. You guys see the points that are up there? Let me make it bigger. I always forget. There we go. So you guys see, I see points that are up there. Do you guys see points that are up there? I see like 4. I see 4. Look, I even made it bigger. You don't see? Actually, I see 5. Watch, some of them are hiding. If I go to mode, and I go to, or maybe it's not mode, maybe it's format. I forget where stuff is. Second, format. And I turn my coordinates off. Coordinate off. And now I'm going to go back to graph. I'm going to make it a little smaller. Go back to graph. Didn't work. Second, format. Do I need my grid off, maybe? It already has grid off. Why isn't it working? Grid color. Let's turn that off. There are totally like 5 points there. They're all hiding. Turn it off! No, I don't know. I think white makes it white, and it might color it off. Oh, axes! That's what I want off. I didn't see that it said axes. It's taking way too much time. This is supposed to be off. Please let it say off somewhere. It's totally supposed to say, there we go. That took way too much time. See, there's points. Why are there just points and they're not connected? Right? Why are there just points and they're not connected? Let's look at that function. All right, let's look at that function. Negative 1/2 to the x, right? Negative 1/2 to the x. If I do a table of values, what happens when I plug in 0? Plug in 0, what do you get? Negative 1/2 to the 0. What's the answer? Anything to the 0 power is 1. What happens when I plug in 1? What do you get? Negative 1/2 to the 1. Negative 1/2. So now here's a trick. Here's like kind of an idea right here. What happens when I square it? It'd be positive 1/4, right? What happens when here's another kind of key point, when I plug in a half? Negative 1/2 to the 1/2 power. You guys just learned rational exponents. What does that rational exponent mean? Square root of negative 1/2. What is wrong with that? Can't have a negative under the radical. It is going to be an I answer. Right? So the reason why it is just a set of points, right? And there's actually some points down below too, is because I've got a point, then I've got something that's imaginary, then I've got a point that's negative, then I've got imaginaries in here, then I've got a point that's positive, right? So I kind of go a point up top, a gap, a point down the bottom, a gap, a point up top. You can't connect those in a nice smooth curve, right? So the rule is going to be that you can't have any negative numbers as a base. So then you can't have any of these negative numbers as a base either. Okay? So if 1/2, 1/3, and 1/7 was our decreasing graph, what do you think 2, 3, and 7 are going to do? Increase. Right? And again, we're going to write all of this stuff up for you. All right, how about 0 and 1? Right? 0 and 1. If I make my base 0 and 1, all right, well, even before I put it in there, I want you to make a table of values with your partner. All right? One of you make a table of values for 0 to the x. One of you make a table of values for 1 to the x. And just use numbers, -2, -1, 0, 1, and 2. All right? Do those numbers. How do I do what? Make a table of values?
Yeah.
Just plug them in. Take -2, plug them in.
Like how do you
I don't want you to do that here. I literally
Oh,
just want you to.
Well, is it 0 to the x?
Are you guys done making your tables? I think you should be. What's this answer? What's this answer?
0.
This answer is 0. You're just probably not putting it in right. Alright? Doesn't that make sense that 0 raised to any power is still going to be 0? Alright? Are you doing 0 or are you doing 1? B and D parentheses around negative 2. What's this answer? What's this answer? 1 to the -2, 1 to the -1, 1 to the 0, 1 to the anything is 1. Alright, what pictures are those going to make? Straight line, right? I'm going to have a straight line at 0. I'm going to have a straight line at 1. Do they look like those pictures? So you can't have 0 and 1 either. So if we go back to our kind of sets, we can't have that either. So we can only have numbers in this category, and we can only have numbers in that category. So let's write that up, right? So these are going to be our rules. I might kind of flip a few pages because I kind of did stuff that I had on separate pages together, right? start with this one first, right? So again, I left out the a there, but it's really a times b to the x. So here's kind of your case one. Case one. When b is greater than 1, we're going to have some common things happen, right, with all of our functions. When b is greater than 1, our function is always going to be an increasing graph. Increasing graph. It's called an exponential growth. Exponential growth. I thought it was something.
You can spell that so correct.
That sounds good. I didn't think it. I didn't All right, it's an increasing graph. It's an exponential growth. What I want you guys to tell me is, what's the y-intercept? I drew it correctly. What's the domain? What's the range? What's the horizontal asymptote? Right? So do that with your partner. I drew the, except for this little squiggly part of the line, like it's supposed to really like go towards the axis, right? But I drew that graph correctly. Right? So try to fill in those items. What's the domain? What's the range? What's the y-intercept? What's the horizontal asymptote? Right? So fill those things in. So that's when b is greater than 1. First case. And this graph is, like an example would be 2 to the x, or 5 to the x, or 7 to the x. They would all look the same. Colton, how about domain? What do you think? Left to right. Domain. And give me a try.
I just said negative infinity to infinity.
Negative infinity to infinity. Everything is used. All right, Ava, how about range? Low to high. So what's the lowest number that we almost hit? 0. Right? So we don't hit it, so it's going to be open, right? To infinity. Yep. How about the y-intercept? Anybody think they know the y-intercept? Adam? 0, 1, I'll say, right? Because if I plug in 0 right there, right, anything to the 0 power is 1. And I'm going to go back to that one. Okay? How about horizontal asymptote? Miles, what do you think? Horizontal asymptote. What line am I not crossing? Is it an x equals or a y equals? So x equals 0 means that any point on that line is going to have an x of 0. So other way around, right? Y equals. So my son was actually, he's in Algebra 1 in the, like, pre-algebra in the middle school. An easy way to remember that, if it's the line that's horizontal, it's passing through the y-axis, so it's going to be a y equals. So whatever axis it passes through, that's what it's going to have, a y equals. All right, now I'm going to change it a little bit. It's going to go back to Adam's answer, right? A y-intercept. If I change this function to 4 times 2 to the x, or 5 times 2 to the x, or 7 times 2 to the x, how do you think it changes the y-intercept? Okay? So think about it. talk about it with your partner. If I plug in 0 right there, okay, plug in 0 right there. Thank you. What is going to be the y-intercept? If I plug in 0, I don't think it's going to be 1 anymore. What do you guys think? Andy, what do you think, sir?
It would go up.
That one would go up, but where would it go up to? It could go down, depending upon the number that I use. So Ryan and Sarah and Jack were having a conversation. What do you guys think it is?
It's whatever A is.
Good, it's whatever A is, right? Because 2 to the 0 power is always going to be 1, and 1 times whatever number that's going to be, right? So when Adam did 2 to the x, 5 to the x, 7 to the x, he said 1, because that's how I drew it, and that was my A, right? So my y-intercept, or my initial point, right, because that's what I said on the other slide, it's even better to say that it's 0, A. Right? All right. What's going to change if I do case 2, where B is in between 0 and 1? This time, let's write it in its true form, A times B to the x. So I'm going to draw a model of it, right? Here's a model of it. So same deal. I already told you guys this one was decreasing. It's called an exponential decay, right? Exponential decay. So does the domain change? Does the range change? Does the horizontal asymptote change? Does the y-intercept change, right? I think those are the 5 things I had on there. So look at all of those answers for that one. Do those answers change when I change the base to a decay? All right? So think about the answer that I put on the other one and try it for this one. All right? Try it for this one. And again, really have that A be in there. Don't just go 0, 1. Right? Let's say it's not drawn to scale. Right? So do all of those things still holds true. So look at the domain. Is it still the same as the increasing one? Look at the range. Look at the horizontal asymptote. Look at the y-intercept. What do you guys think? Grace, how about domain?
Domain is going to stay the same.
Stay the same, negative infinity to infinity. Freya, how about the range?
It's going to be 0.
So stays the same. How about horizontal asymptote, Elizabeth? Still x equals 0, right? And y-intercept? Still 0, A, right? So the only thing that's changing is the direction, right? Increase versus decrease, right? And it's all dependent upon that base. All dependent upon that base. All right, so here are a couple. Tell me whether they are exponential functions or not, right? So are they exponential functions? And if it's a yes, tell me whether it's a growth or a decay. Right, so are they exponential functions? Is it a growth or a decay? Is it an exponential function? Is it a growth or a decay?
X counted.
All right, Graham, how many are exponential functions?
The first one
All right, you gave up both, right? So the first one and the last one, so we had two of them. So now we just gotta decide if it is a decay or a growth, right? Decay or growth. Why aren't the middle two exponential functions? Right? What's wrong with them? What's wrong with them? Addie, why aren't the middle two? It's actually the same reason.
Is it because they're labeling the as an
Say that the b is an x, that's fine, right? The base is a variable rather than the exponent being a variable. All right, so Jacob, what do you think? Growth, decay, one of each. First one's growth. How about the second one? What did we say makes them a growth or a decay? Right, Andy? He cheated, he dropped it. Did you cheat? Did you drop it? You cheated, he dropped it. They do go up, so that's an okay cheat. But how about if you didn't have a picture in front of you? What's going to make that? a growth?
Oh, like where the A what?
Not necessarily rear the A
Oh,
and
it's
B
like
are,
a negative.
but what one of them is. So which one do you think is more important, the 5 or the 3? 5 or the 3? I heard Paxton say 5, I heard a couple of people say 3, so we got both options. What did we just go back? We just gave you 2 options, right? Look at what I just said, depends on what it is, right? B is greater than 1, right? Look at where the B is. The B is attached to the X, so that's going to make it a growth. B is in between 0 and 1. B is attached to the X, right? That's what makes it a decay. So whatever is attached to the X is going to determine whether it's a growth or a decay. So since that B is greater than 1, it makes it a growth, right? I can disguise a decay as well. Watch, if I write it like this, that B right now is a 3, right? But look at what I did to the exponent. What does that negative do to the base that's right next to it? What should you do to it? That was number 1 of your quiz, right? I got to change that to be 1/3 and have a positive x, right? So this right here would be a decay. Okay? All right, let's see what I got next, because I forgot what I had after this. I think you guys are okay with those 2. I don't think we need to do those. Let's do those 2. All right? So come up with some points that you're going to graph. All right? So let's maybe graph. I'll give you some nice points. A nice point would be, I don't know, it's going to be a fraction anyway. So -2. 0 would be a nice point. 1 would be a nice point. There's going to be no other really nice point. So let's try 3. So plot those points and graph it. And then on this one, again, it really doesn't matter. So let's go -1, 0, 1. Actually, we'll do the same points. -2, 0, 1, and 3. So again, if each of you want to do one, right? And then we can look at what these look like. I hope you would guess whether it should be a growth or a decay first, based upon what they look like. And I would hope the points would help you verify that.
And my bag.
And you probably have to plug in more than 4 points. Just go up there, Tyler. Thank you. So I'm hoping you're gonna think this one's a decay. I'm hoping you're gonna think this one's a growth based upon their faces. So I plugged in the two easy points first, right? So I did the zeros, so it's just going to be my A value. So then I plugged in the 1. It's really just going to be A times B. So if I plug in -2, it's going to be 6 times 2 squared, so that's 24. If I plug in 3, it's going to be 6 times 1/8, so that's 6/8, which is 3/4. So -2, 24, I don't know, way up there somewhere. 3, 6/4, it's going to be really close to it. So yes, it is a decay. We'll finish the other one up when we come back. Alright, so let's look at this last one, guys. Then we are going to do some kind of going backwards. If I give you a table, get a function, and then we're going to do some word problems. And then we'll be done. Okay? Alright, so this last one, right, I filled in the last points. You had -2, you got 2/9. We had 3, you got 54. Right, so that's a growth. Okay? So, I mean, anytime you have a function, you can go and put some points, right? But in general, right, in general, 0, A will be your y-intercept, right? So that's an always. Your domain will be -infinity to infinity. Your range will be 0 to infinity. Your horizontal asymptote will be y = 0. Right? And then we've got our two cases. So if b is greater than 1, it's going to be our growth. So it's going to model this. And then if b is in between 0 and 1, it's going to be our decay, and it's going to look like that. Right? So these are all for exponential functions just in this form, right? Because one of our other lessons is going to have transformations, right? So we're going to modify them by adding and subtracting to the x, adding and subtracting to the whole function. We're going to make a negative, right? And that's going to be a reflection over the x-axis, right? So these are all kind of guaranteed items for something in the general form of a times b to the x. Okay? All right. So now if I go backwards, if I give you a set of points, how are we going to tell if it's exponential and if it is, and what is the equation if it is exponential? All right, so you look at the x's, right? And it goes in order 1, 2, 3, 4, 5, 6. Okay, what's happening with the y's? How are we jumping with the y's? They are more. You're correct. But how much more? Huh? They're double. They're double. And that's what you want to look for, right? You want to look for that it's the same constant amount. As long as these numbers are consecutive, right? all of the numbers are doubling, right? So that's going to tell you that, yes, it is an exponential function, okay? So there's different ways that we can come up with the function. I like to do it by just picking 2 points and doing simultaneous equations, right? So y equals a times b to the x, okay? So now you could really pick any 2 points that you want, but if there is the point 1 comma 3, so if there's a point that has an x as a 1 or an x as a 0, if there's both of them, then you're golden, right? That's going to be really easy. But if there's at least one of them, you want to pick that point, okay? The other point, it doesn't matter, right? It doesn't matter at all. So Travis, pick another point for me. 3 and 12, okay? So these are going to be our 2 points that I'm going to use. Okay, so I've got an x, I've got a y. So I'm going to plug it in. So I'm going to take my 3 and my 1, plug it in. 3 equals a times b to the first power. Right? So I've got an equation. I'm going to take the 12, plug it in. 12 equals a times b cubed. I have 2 equations and 2 unknowns. So I should be able to solve it. How can I solve them? How can I take those 2 equations and put them together? You can set them equal to each other. So what variable, Elizabeth, is easiest to solve for, A or B? A, right? So that's kind of what you want to do. You want to say, okay, 3 equals AB, so 3 over B equals A. 12 equals A times B cubed. 12 over B cubed equals A. So they both equal A, right? So take those 2 items and set them equal to each other. 3 over B equals 12 over B cubed. Just multiply and solve, right? We got 12b, we got 3b cubed. I can divide each side by b to get rid of a b. So that goes, I get b squared. I divide by 3, I get 4 equals b squared. Alright, so when I square root both sides and I solve it, b is going to be what? Square root both sides. I'm okay with the 2, but what else does it can it be? Plus or minus 2 really, right? But if you look at where b is, we got to go to our rules for exponents, right? Exponential functions. My base can't be negative. So as long as it's a b, right? As long as it's the base, I can only have a positive b, right? So b is 2, right? b is 2. I'm going to take my 2, I'm going to plug it in. I'm going to plug it into this one because it's pretty easy. So then a is 3 halves. So here's my function. 3 halves times 2 3 halves. Right? I could check it. I could take a point. If I plug in 424, it better work. So if I plug in 4, 2 to the 4th is 16. 16 times 3 is 48. 48 divided by 2, 24. So it checks. You guys try that one. Okay, you guys try that one. Again, you can pick any 2 points. Any 2 points. If you're doing the 0.25, I probably change it to a quarter. If you're doing the half, the 0.5, I would change it to a half. I would leave it as a fraction. Right? It's easier when you do it as a fraction. Again, you can pick any 2 points. Some points are better than others. If you want to do it just like we did it on the last one, I pick 1, 2, and then I probably pick the 2, 4 to make it easiest for you. If you want to do it just like we did the last one. That's your x, right? Because that's y equals a times b to the x, right? So when you're plugging in y equals a times b to the x, this is where you plug in this column, this is where you plug in that column. Right, because isn't xy just a point that I could plug into that function?
Oh, so for the 1 and the 2, and
Mhm.
b2 equals ab to the 1.
Yep.
Okay.
Did anybody pick the 0 point? If you pick the 0 point, it makes it nice, right? It automatically gives you the a value if you pick the 0 point. If you don't pick the 0 point, it's totally fine. You're still going to be able to solve it. It's just going to be a little more work. Okay, so I'm going to do it 2 ways. I'm going to pick the 0 point, and I'll pick 1, 2. You guys see how I did that top one, right? Because I told you guys when we started, if you're given, right, if you're given the 0 and the 1 point, that's a bonus, right? So look what happens if you pick the 0 point. If you pick the 0 point and you plug it in, b to the 0 is 1. So that cancels out, and you automatically get your a value. So that's a key point to pick. So then I immediately plugged in my a, and then you go plug in the second value, and you automatically get your b. All right, so I did the same thing. I did relatively the similar work. I picked 1, 2, and 2, 4. So I plugged in 2 and 1. I plugged in 4 and 2. So this is the same method as the last one. A equals 2 over b. A equals 4 over b squared. I set them equal to each other. 2b squared equals 4b. I canceled out a b, I divided by b, and that's okay to do in this problem. Alright, so then I divided by 2, and I got b is 2. Once I get b is 2, I'm going to go back up here, plug it in. A is 2 over 2, so a is 1. Okay, do you guys want another one of those? Do you think that's okay? We got last word problems to do. Alright, so let's try a couple of word problems. Right? So, this is still exponential, right? But I told you we would change that b a little bit, right? So, a times 1 plus or minus r to the t. So, this is still an exponential function, right? But it just kind of gives a model to indicate a percent increase or a percent decrease, okay? So it says, how much money am I going to have after 4 days if I start with $10 in my wallet and I spend 50% of my money each day thereafter, right? So You're gonna set it up. Starting amount is $10. So you have $10. You're spending 50%. So that means it's gonna be a decrease. It's a decrease of 50%. If I make it y equals that to the t, well, that would be an equation that I could make, bless you, for however many days that I want. But I want to know 4 days. So I'm going to take 4, I'm going to plug it into my t. So you guys do that in your calculator. All right, see what you get. And leave it not rounded, so give the full answer. So I kind of want to ask you a question after that. You got to make sure you're doing correct order of operation. So the exponent has to be done before you multiply. So I heard Jordan say 0.625. Is that okay? Do you guys get that? Would you ever end up with 0 after however many days you do this? Would you ever end up with 0? Like if you do it for 100 days, would you end up with 0 as an answer? Why not?
Half of the number is
Half of the number is never 0. Right? Does that make sense? Like if we were to round off in real numbers in like 2 decimal points, yeah, we end up with 0. Right? But in actuality with numbers, right, you would never end up with 0. All right, let's see if you guys can write an equation for one of them. All right, so this one says, that one's boring because it's pretty much the same thing, right? All right, so this one says an initial population is 15,500, and the population is dropping every 3 years. Write an exponential function, right? And you don't have to graph it if you don't want to. What's the population after 5 years, right? So write an exponential function, and then determine the population after 5 years, right? Starting at 15.5. And let's maybe round to the whole person, right? Round to the whole person. So again, what's that initial amount? That's your A. Then it's another decrease, so that's why it's going to be a minus. Again, round to the whole person, whole person. Cynthia, what do you get? 13,310. Do you guys agree with that? So on my decimal, I got 0.3774, right? But it's 13,310. Right, so you start with that 15,500. You're decreasing 3% every year. So that would be your equation. All right, let's see if I have an increase one, just so we can do an increase. This is an increase one. All right, so I think you guys are getting that down. So let's just do one increase one, and then we're good to go. All right, so try an increase one. Gianna, what do you think for an equation?
I suppose
Good, so 1 plus 0.14 to the t. So if I simplify it, right, 114 to the t, I get a lot of whales. 57,990? Is that what you guys got? Right, 0.55? That's a lot. Right, I did 39 years, 2020. Was that good? Exponential's okay, right? All right, so this is the page that I forgot to put in your packet, page 494. So I want you to do 7 to 15. So what I did was I linked it to the planner. I don't know if grades are going to come up, so give me a second. All right, so if you go on the planner, right, if you go on the planner, I put 7 to 15 on the planner, and I linked that page on the planner as well. Should come up, right? So that's the page, I mean, if you have a book too, I know we don't use the book tons, but 7 to 15. Okay? And if you guys still have a book and you find that you never open it, bring it in. Right? Might as well return it now than return it at the end of the year. Some